Hello students, in this video we're going to talk about the composition of functions. When we compose two functions together, it is simply putting one function into the result of another function. So I'm going to start out by just talking about an evaluation problem. We all understand at this point that if I give you a function like f of x and I say that it is equal to 2x plus 1, and I ask you to evaluate f of 2. All I'm asking you to do is take whatever you see inside here, which is a 2, and every x is getting replaced with that value. So this becomes 2 of x plus 1, but every x gets replaced with 2. And then I simplify, and I end up with a final answer of 5. That is evaluating a function with a numeric value. Well, now I want you to do the same thing, but instead of evaluating with just a number, you're going to evaluate with a function. So what I mean is you're going to take a function like f of x, and we're going to say, okay, we have 2x plus 1, but now I want you to evaluate a f of 3x plus 2. The idea is going to be the same thing. Everything inside 3x plus 2 is going to replace every x that you see within your function. Now, the cool thing about it is because 3x plus 2 is a function, I could give it a name. I could call it g. I could say 3x plus 2 is g, and so maybe I want you to find f of g of x. So when we think about the composition of two functions, I've shown you basically what we're doing here, where we have f of g of x, and we're just calling this function 3x plus 2, the function g. So this brings us into the idea of composition of functions, which states if we have two functions, I have some f of x function and I have some g of x function, I can compose two functions, so f composite g of x, which simply means I am taking the f function and I am evaluating every x in that f function as g of x. Okay, you can also compose g composite f of x, and that says you're taking the g function, and for every x that you see, you are evaluating the f function. Okay, so again, this little circle, this little symbol that I have right here, I'll highlight it. This little circle, it's kind of like a little O, or sort of looks like a multiplication symbol. It's not a filled in dot, so multiplication actually has that thing filled in. This one is open, and so that represents the symbol for compositions. So it lets me know that I am composing two functions together. Okay, so let's do an example. Let's say I have a function, f of x, and I am identifying it as 2x plus 3. And then let's say I have a g function, and I want to identify that as x squared. And I ask you to evaluate f composite g of x, and I ask you to evaluate g composite f of x. And we want to see, do they represent the same answer? So probably the easiest way to do this is to rewrite the notation as f of g of x. And then in the other case, it's g of f of x. You'll notice that the way I'm figuring that out is whatever letter comes first represents my outside function. Same thing over here. G came first, so that represents my outside function. So I'm going to write my outside function, which is f, and that is 2x plus 3. But for every x that I see, I'm going to replace it with the g of x function, and that's going to have to go right there. Well, g of x is defined by x squared. And I simplify, and there's nothing else to do, so I have found the composite of these two functions. Now, on the other side, my g function is equal to x squared but for every x I see, I'm going to replace it with f of x, and f of x is being identified as 2x plus 3. And that means I have 2x plus 3 times 2x plus 3, and I'm going to have to FOIL. And that's going to give me 4x squared plus 6x plus 6x plus 9, which is equal to 4x squared plus 12x plus 9. And so what you'll immediately notice is that the F composite G is not the same answer as G composite F. So that lets me know that composition of functions is not commutative, that order does matter. If I want to do F composite G, I have to make sure I choose the F function as my outer function, because I won't get the same answer if I don't. Now, another thing to know is that you can actually compose a function within itself. So I could actually ask you to find F composite F of x. And it's a little weird, right? But using the same values, that's saying f of x. So my outside function here is the f function again. So I'm going to write out my f function, which is 2x plus 3. But again, for every x that I see, I'm replacing it with whatever is defined by f of x, which again is 2x plus 3. And I simply do the algebra to simplify. And then I combine like terms. And I am left with a final answer of 4x plus 15. Okay. All right, so I'm going to give you some problems to work out on your own. If you can go ahead and pause this video once I've written the equations and try these on your own. All right, so looking at this, my inner function here is g of 6, and that's looking a little nasty. It'd be rather nice if I could rewrite that. So I'm just going to try to focus on simplifying the inside first. So if I have g of 6, that is my g function. My g function is equal to x minus 4, but for every x that I see, I'm going to want to replace it with 6 because I'm being asked to evaluate the g function, and that's just equal to 2. So that means that whole thing is equal to 2, so now my equation is just f of 2. Makes it a lot easier to solve. So then I go to my f function, which is x squared plus 2x. And every x that I see is going to be replaced with the value 2. So 2 here, 2 here. That gives me 4 plus 4, which is equal to 8 as a final answer. If I look at the second problem, f of negative 3, I could go ahead and evaluate that first. So I'm going to go to my f function. Every x that I see is getting replaced by negative 3. And when I fully simplify that out, I end up with a positive 3. So now I am left with g of positive 3. And I go to my g function, which is x minus 4. Plug in my 3 because every x is getting replaced by the value 3. And when I complete that problem, I end up with the solution of negative 1. F composite g of 0 is just saying f of g of 0. So again, I can focus on simplifying the inside, which would be 0 minus 4, which is negative 4. So now I'm working with the function f of negative 4. X squared plus 2 times x. Every x is getting replaced with negative 4. And when I go to simplify that, I end up with a positive 8. And in my last example, I have g of f of 5. Focus on the inside. So that'd be 5 squared plus 2 times 5. That's going to give me a total of 35. So now I'm focused on g of 35. If I plug in 35 for x minus 4, I'm left with the solution of 31. All right, I hope you found this video helpful. As always, if you have questions or concerns, please don't hesitate to reach out.